Rationalize each denominator and then simplify. So we are not allowed to have radicals in our denominator, correct? So if they give us a radical in the denominator, our goal is to rationalize the denominator, okay? Now, yesterday we dealt with monomials on the bottom, monomial radicals on the bottom, and then we just multiplied by that monomial, that's what Ben said, and then it would go away, right? That was what we agreed, the radical sign would go away. But we had a monomial on the top and a monomial on the bottom. Today we're going to look at having a monomial on the bottom, but a binomial on the top. We're still going to deal with it in the same way, though. So, I have a root 3 in the bottom. That is my issue. I can't have a square root in my denominator. I must rationalize my denominator. What does rationalizing my denominator mean? Making it be a rational number, which the square root of 3 is not. So, how do I get square root 3 to go away? Times it by square root 3. And what I do to the bottom, I have to do to the top. Because I'm making equivalent fractions. So the bottom should turn out right away. After this step, your bottom should immediately be rationalized. Or you messed up, which means the radical sign should go away. What's root 3 times root 3? 3. Then we have to distribute in the top. Root 3 times root 3 is 3. And then negative 1 times root 3 is negative 1 root 3. Now, the only way I can take a number out is if I can take it out of every single number in front of the radical or number by itself. So I have a 3, a 1, and a 3. A 3, a 1, and a 3. Can I take something out of those? No. Done. Box it. I also do have to check the radical and make sure I can't reduce it, which is a root 3, which I can't reduce. It's as low as it can go. If it was like root 24, I'd have to reduce it. Okay? For B, it's a monomial in the denominator. What's the problem about the 3 root 6? Is the 3 my problem? No. Is the root 6 my problem? Yes. Do you see that it's a monomial? There's no plus or minus signs between them. So I can just multiply by root 6 when it's a monomial. Multiply by root 6. So I'm going to get on the bottom 3 times 1, because there's just a 1 in front, so 3. And then root 6 times root 6 is 6 in brackets.
Like, distribute it, so it's like, what is 12? 6, 12. 6 root 12 plus 2.
I'm doing the denominator, but yeah, we will do that in the numerator. So we go 3 root 6 in the denominator. Then in the numerator, we're going to go 6 root 2 times root 6. Well, that's 6 times 1, which is 6. And then root 2 times root 6 is root 12. Plus 2 times 1 is 2. Root 6 times root 6 is 6. So now I have 6. Can I break down root 12? Yes. What and what? 4 times 3. 4 comes out and it's a 2. Plus 12 over 18. And so I'm going to get 12 square root 3 plus 12 all over 18. Is there something I can take out of all 3? A 6. Has to come out of every single term. So anything with a plus or minus sign. So this is a term, this is a term, this is a term. It has to come out of all of them. So 12 divided by 6 is 2. 12 divided by 6 is 2. 18 divided by 6 is 3. And I'm left with 2 root 3 plus 2 all over 3. I can't reduce the radical anymore. It's a root 3. And I can't take any more numbers out. So I'm done. You try the next two with variables. So I'm going to multiply this one by root x, and this one by root 2x. Yeah. Try them out. So for the first try, we're going to multiply by root x. Top and bottom. So on the bottom, root x times root x is x. Please make sure that you put equal signs running down the left-hand side, because each one equals the next one equals the next one. On the top, I'm going to get square root of 18x times root x. Is square root 18. What's x times x? X squared. Minus square root 8x times x is square root 8, and then x times x is x squared. What happens when I have x squareds? They can come out as a x. So now I have x root, now wait a second, 18. Can I break it down into anything? What? 9 and 2. Oh, I hate this. Keeps trying to connect the numbers. 9 comes out and it's a 3. Minus x. 8. Can I break it down into anything? 4 and 2. Ugh. 4 comes out and it's a 2. All over x. So now I have 3x square root 2 minus 2x square root 2 over x. And I'm done? Am I done? Nope. The top is both root 2's, correct? If I have root 2's, I can put them together, can I not? Because they're like terms. So what's 3x minus 2x?
1x.
1x, and then just root 2, right? Because they're like terms. So 3x root 2 minus 2x root 2 is x root 2. Because 3x minus 2x is x, and then the root 2 gets written over x. And what happens with these x's? They cancel, so my answer is root 2. Then we're going to look at C. I have to multiply by root 2x. So I'm going to get root 2x times root 2x is 2x. Square root goes away. Then I get 2 times 1, which is 2. And then root x times 2x is 2x squared. And then negative 8 times 2x is positive root 16x. Now this x can come out as an x squared can come out as an x. So now I have 2x root 2, and the 16 can come out as a what? 4. Plus 4 root x over 2x. I can't put the top two together because one's a root 2 and one's a root x. They're not like terms. But can I take anything out of the coefficients? A 2. 2 out of here, I'm left with a 1. A 2 out of here, I'm left with a 2. 2 out of here, I'm left with a 1. So on the top, I have x root 2 plus 2 root x over x. Yeah.
Why did the, so when root 16, oh, because it's perfect square.
Yeah.
Number 20.
No, you're not. Okay. We'll try and use a different word next time. Like, oh my goodness, that was a mistake. Or something, right? Okay. We're going to flip to the next page. What's different here?
Binomial bottoms.
Binomial bottoms. Binomial bottoms. You might want to grab out a separate sheet of paper to do these on because they take up a lot of room.
Oh.
You might just want a separate sheet of paper to the side. So, we still want to rationalize each denominator. When the bottom was a monomial, we just multiplied by whatever the heck the radical was in the denominator, correct? When our denominator is a binomial, the way to rationalize the denominator when it's a binomial is to multiply by the conjugate. Remember we talked about the conjugate yesterday? It was same two terms, opposite sign in the middle, correct? Same two terms, opposite sign in the middle, because it will get rid of the middle terms. The middle terms will cancel if you multiply by the conjugate. That's what we learned yesterday. So when it's a monomial, we multiply by just what the radical is. When it's a binomial, so two terms, we multiply by the conjugate. So root 3 and 1 are going to stay the same, and the plus sign is going to become a negative. That's it. So we're going to multiply by root 3 minus 1. Then we're going to multiply the top by root 3 minus 1. Like I said, you might want a separate sheet of paper. When there's a monomial on the top, it's not bad, but when there's a binomial on the top, like the last one, it's going to be more work. Okay. So I'm going to have to distribute the top. I'm going to get 4 times root 3, which is equal to 4 root 3. 4 times negative 1 is equal to negative, 4 over, and then we have to FOIL the denominator. We have to FOIL it because it's a binomial times a binomial. But if you actually pick the correct conjugate, the middle terms will be the exact same opposite sign and cancel. So you'll end up with 2 instead of 4 terms when you FOIL the bottom. So let's see. Root 3 times root 3, first times first, 3. Then outside, so we did first times first, then we do outside times outside. Root 3 times negative 1 is negative 1 root 3. Then the inside times inside. Positive 1 root 3 is plus 1 root 3. What happens to these two middle terms? They cancel, so I know I actually did something correct here. If I don't multiply by the conjugate, they will not cancel. Go back, try again. It could be that you just multiplied wrong, and you still are actually doing the conjugate. And then we have to do last times last. 1 times negative 1 is negative 1. Now we know we did not mess up if our denominator does not have a radical, because that's why we're rationalizing. Rationalizing the denominator means we're getting rid of the radical symbol, correct? So if when I multiply here I still have a radical, something is wrong. Okay? So I multiply by the conjugate, my denominator is now 2. Because it's 3 minus 1. So I did something good. Oops. Except for that. I did this good. And I scrolled weird. Hands off. And in the top I have 4 root 3 minus 4. Can I put them together? One's a root 3, one's a constant. Are they like terms? No. Can I take anything out of all of the terms? What? A 2. I can take a 2 out of the 4, a 2 out of the 4, and a 2 out of the 2. So I'm going to get 4 divided by 2 is 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Do I need to write the 1 if it's in the denominator? No. Do I have to write the 1 if it is in the numerator? Yes. So my answer is going to be 2 root 3 minus 2 box it. You're going to try the try and the B, please. Try the try and the B. So for the try, what do I have to multiply by this time to get to rationalize the denominator, to get the radical to go away? Square root 5 plus 5. I'm just giggling because Izzy is handwriting it instead of saying it. Air writing, air quotes. 5. Yeah. True. That's right. Okay, root 5. It's connecting my multiplication symbol. Plus 5. What? Oh, no. So when we multiply the denominator, we get root 5 times root 5, which is 5. And hopefully our outside and inside terms that we multiply will go away. If not, You messed up. Okay? All right. Root 5 times 5 is 5 root 5. Root 5 times negative 5 is negative 5 root 5. And after this spot, I should be able to do this immediately. If I can't, something went wrong. Okay? And then negative 5 times 5 is negative 25. And then on the top, we distribute. Root 5 times root 5 is 5. Root 5 times 5 is 5 root 5. So we have 5 plus root 5. And there better not be a radical in our denominator. We oopsied. 5 minus 25 is negative 20. I left the 5 off. Negative 20. What can I take out of all of them? 5s. So a 5 out of 5 is a 1. Do I still have to have the 1? Yes, because it's 1 plus something. If you get rid of it, it's 0 plus something, which is totally different. This 5 turns into a 1. Do I have to keep that 1? Technically, no, because 1 root 5 is still 5. And then this is negative 4. So we get 1 plus root 5 divided by negative 4. Box that baby. Sure. For b, what do I do? Multiply by the conjugate, which is root 2 plus root 3. So we multiply by root 2 plus root 3. Root 2 plus root 3. We can write it in brackets. It's easier. So in the bottom, my middle terms better go away, and I better not have any radicals, or I did not multiply by the conjugate. So root 2 times root 2 is 2. Root 2 times root 3 is plus root 6. Negative root 3 times root 2 is minus root 6. They cancel. I'm happy. Negative root 3 times positive root 3 is negative 3. No radicals left. Makes us happy. In the top, root 15 times root 2 is root 30. Then root 15 times root 3 is root 45. Root 30, can it break down into anything? No. Root 45, can it break down into anything? Yes, what?
9 and 5.
9 and 5. The 9 comes out and it's a 3. And then 2 minus 3 is negative 1. Now you can write it over negative 1, which I'll show you. You can go root 30 plus 3 root 5 over negative 1. It's not wrong, but the answer won't be there. What they'll do is they'll actually distribute the negative 1 into the top. Because you can take the negative 1, if it's only a negative 1, you can bring it to the top. So, you can go negative 1 times root 30 plus 3 root 5, only if it's a negative 1. And then you get negative root 30 minus 3 root 5. Or if you want your signs to change, you can just multiply them all by negative 1. Negative 1, negative 1, negative 1, that will become a positive 1, right? The same thing. So if you have a negative 1 on the bottom and you want it to go away, multiply every term by negative 1, that'll become a positive 1. It'll do the same thing. Because negative root 3 times root 3 is negative 3, right, Carson? You have a negative sign. Okay, what's the difference between this one and the last 3? The top is actually a binomial, so not only will we have to FOIL the bottom, we're going to have to FOIL the top, But does it make our decision at first what we do different? No, we have to multiply by the conjugate, right, Kate?
Yeah.
Yeah. So we have 2 root 6 minus root 5, and we have to multiply by 2 root 6 plus root 5. So if we go to FOIL the bottom, we get 2 root 6 times 2 root 6, which is actually 4. Root 6 times root 6 is 6 in brackets. Then the outside, 2 root 6 times root 5 is 2 root 30. Inside, 2 root 6 times negative root 5 is negative 2 root 30. And what do these two do? Cancel. And if they don't, you messed up. And then negative root 5 times root 5 is negative 5. Now it's going to be 24 minus 5, which is 19, which is good, because that means our bottom won't have any radicals. Correct? Then we have to do the top. 2 root 2 times 2 root 6 is 4 root 12. Then we do outsides. 2 root 2 times root 5 is 2 root 10. Then negative 6 times 2 root 6 is negative 2. Root 6 times root 6 is 6 in brackets. And then the last term, negative root 6 times root 5 is negative root 30. 4 root 12 is the only one I can reduce, hey? Root 10 can't break down, root 30 can't break down, so it's only the 12. So I'm going to get 4 root 4 times 3, and that 4 comes out and it's a 2, plus 2 root 10 minus 12 minus root 30 all over 24 minus 5, which is 19. None of these have like root 3, root 10, root 30. None of them are like radicands, right? So they're not like radicands. Can I put them together? No, it's just going to have 4 terms, and it's nothing pretty, and that's completely fine. So you get 8 root 3 plus 2 root 10 minus 12 minus root 30 over 19. Box it. Your homework questions are page 290, 10, and 11. All binomial denominators, I believe. No, I wanted a monomial. So 7 of the 8 questions are binomial denominators. Eight questions, that's nothing. Oh my goodness. You have 18 minutes. Technically more like 15, but get working. You could finish these before the weekend and not have any homework, right?